Okay, guys, so to solve a triangle is putting all the trig work and all the right triangle work all together, okay? So if your directions just say solve the triangle, it's telling you that you need to find every piece of the triangle that you can, all right? And you're going to have to use a combination of Pythagorean theorem, um, maybe even Pythagorean triples or special right triangles, depending on the triangle, and right triangle trig to put it all together. Okay, so in this example, if you're solving the triangle, you've got your 31 degrees and your 21 measure hypotenuse, and you need to find x and y, but we're also going to have to find angle B right in there as well. Okay, now angle B should be easy. If you know 90 degrees and you know 31 degrees, then what's the measure of angle B? You just subtract the 90 and the 31 from 180, and angle B is 59. Okay, degrees, that is. Don't forget your degree symbol, okay? Now, when it comes to solving for x and y, since I only know this one side, and this is not a special right triangle, I'm forced to use trig, right? My suggestion to you is to always use the angle or something that's given to you, just in case you subtracted wrong and you got the wrong answer here. If you're using a wrong angle measure in a trig function, you're obviously going to get the wrong answer. Okay, so I would recommend sticking with the 31 degrees that was given to you. Okay, so from 31 degrees, the 21 is the hypotenuse. If I were solving for x, the x side would be the adjacent side to the 31, right? So I'm going to go cosine of 31 equals adjacent over hypotenuse, right? So the adjacent is the x and the hypotenuse is the 21. Okay, to solve that one, you're just multiplying by 21. Okay, and you should get for that one 18 when you plug that in your calculator. If you don't get 18, that means your calculator is probably in radians instead of degrees. If you don't remember how to fix that, let me know. Okay, and then once you have this 18, you can do one of two things now, right? If you know that that's 18 and that's 21, you could use the Pythagorean theorem just to find y, or you could use trig again. Doesn't matter to me, whichever one you're more comfortable with. I'm going to use the trig just for added reinforcement, okay? So again, from 31 degrees, you have the hypotenuse is 21. Y would be the opposite side, right? So opposite and hypotenuse, you're using sine. So sine of 31 equals y over 21. Okay, so again, you're just going to multiply by 21, multiply by 21. So you have 21 times the sine of 31 is going in your calculator, and you get a value of 10.8. Okay, so you have 59 degrees on the missing angle. You have 18 for x using cosine, and you have 10.8 using y and sine. Okay, so that's one example. Example number 2. This one has no angles given, so we're going to have to use trig to find the angle measures of those. But first and foremost, let's take a look at that x. I know right away that this x is 25. I don't even need to use the Pythagorean theorem because it's a Pythagorean triple, 7, 24, 25. If you forgot, you can use the Pythagorean theorem. It's not a big deal, okay? Then I'm going to come in, I'm going to find angle A, and I'm going to find angle B. Again, I would refrain from using this side as that's the one that you found on your own. And in case you did something wrong, you don't want it to produce a wrong answer going forward. So I would stick to the 7 and the 24, right? So from angle A, the 7 and the 24 are the opposite and the adjacent. So for opposite and adjacent, I'm going to use tan, right? So tan of A equals 24 over 7, okay? And when you're solving for an angle in your calculator, we're typing in inverse. Okay, and angle A here is 73.7 degrees when you use inverse tan. Okay, 73.7 degrees. Now, once you have that 73.7, I don't even need to use any other trig or anything like that, because if I know 90 and I know 73.7, then I know that this one must be 16.3 degrees. So you've got 16.3 degrees, 73.7 degrees, and 25 on that hypotenuse using your Pythagorean triples. Okay? Last example. Okay, again, no angles, but this time I'm forced to use the Pythagorean theorem to figure out what x is, because this is not a special right triangle, right? So I go x squared plus 19 squared equals 34 squared. Okay, when you do all that out, this ends up being 28.2. Okay, and a quick way to check just to make sure that you didn't royally mess something up is look at the hypotenuse. The hypotenuse still has to be the longest side of the triangle, and it is longer than that, so you're on the right track somewhere, okay, just in case you think you might have messed something up. All right, and again, I'm not going to use this value. I'm not going to use this 28.2 in my trig just in case I mess something up on that. I'm just going to stick to the 19 and the 34. Okay, so the 19 and the 34, let's say from angle A, okay, I have the, sorry for the light, I have the adjacent side and the hypotenuse, which means I'm using cosine. So cosine of A equals 19, over 34. And then that means in your calculators, you are going to be using the inverse function. So inverse cosine of 19 over 34. Let me get that without a glare so you can see it. All right. And when you type that in, you should get to the nearest tenth. Pay attention to what the directions are telling you, if it says to the nearest tenth or the nearest hundredth or to the nearest degree, okay? But this comes out to be 56 degrees. And then once you know that this is 56 degrees, you just use subtraction from 180 to find out that that's 34 degrees down there in angle B, okay? And that is how you solve a triangle completely.